All right, class, let's look at a little more challenging example. This has got more going on, but we can follow it for this every resistor component. We can use this Ohm's law. First, it asks us to figure out what's going on at I2. And remember, I2 is over here. So we've got I2 going across this 2 kilo ohm resistor, and our voltage drop is going this way. So our sign for this one, I want to be careful here, our sign is going to be negative. So if we did our V equals IR, we wouldn't want to use negative IR for this particular case because our voltage drop and our current drop are in different directions. So if you rearrange this, we're going to look like this is V over R, but this is going to be negative V over R. Our voltage in this case is 0.5882, and our resistance is in kilo ohms. So we could also write this as, you could also make a little change here and make this 2,000 ohms, which I think I'm going to do here. I'm going to erase this, make things a little easier for me. I'm going to make this 2,000 ohms. And if we do that, this is going to give us a pretty small number here. Just a second. 0.5882 divided by 2,000. It's going to give me a very small number here. This is a very small voltage and a very high resistance. This is 0.000294, and this is going to be in amps. One step moving this 3 over would be milliamps. We actually want to go to microamps. I know that sounds kind of ridiculous, but a lot of measuring devices might be working in those sorts of ranges with very small currents, right? That's pretty common for a control voltage or control current to be pretty small. Not usually in the microamp range, but in the, yeah, I would say pretty common in that range here. All right, let's take a look at this one. Let's take a look at voltage 6. In this particular case, we've got our current going across this way. We've got our voltage drop from positive to negative going this way. So in that case, voltage and current are in the same direction. So we have positive IR in this case. Our positive voltage is 1.61 milliamps. We're multiplying that by our resistance, which in this case is kilo ohms. Now the nice thing about working with these units here, if I've got milliamps over here and I've got kilo ohms, these cancel out. This just becomes 1.61 times 6, which is 9.66. Let me make that change here, 9.66. And we're going to make that in terms of amps times resistance is going to give me our voltage, which we expect. And this is just going to be in volts. So now I know the voltage across that as shown by the signs there.